This video is going to discuss the distributive property. Now, the real name of the distributive property is actually the distributive property of multiplication over addition, or the distributive property of multiplication over subtraction. It kind of just depends on what you're dealing with. But really, this can be used when you want to multiply a number by a sum or multiply a number by a difference. So if you look at it algebraically, this is what it looks like. You've got your nice equation with an expression on each side. The expression on the left says A times the quantity B plus C. So we want to multiply a number A over the sum of B plus C. Well, that's going to be the same as A times B plus A times C. So really all we've done is, instead of adding these up, this B and C, and then multiplying by A, which would be appropriate for the order of operations, we can actually do something a little different. We can take this number A, or the variable in this case, we don't know the number, and you can multiply it by B, and then multiply it by C, and then just add those two products. So some people, a lot of the times, will kind of draw little lines to help them do the problem. So if we look at this first example, and we'll use numbers first because it's easier with numbers, and then we'll use algebra to show you how we can extend it a little bit. So if we have the number 5, and we're going to multiply 5, let's say 7 plus 4. Well, we could say 7 plus 4 is 11, and then 11 times 5 is 55. Or we can say 5 times 7, and I'll just write the whole thing out, plus 5 times 4. So in this case you have 35 plus 20, which is the 55 that we saw previously. Now at first glance you might say, well, why in the world would we want to do all those extra steps if I can just say 11 times 5 is 55? Well, you won't always be able to add these numbers up. In some circumstances, they might not be numbers at all. They might be variables. You might have something like 5 out here, but inside you have x plus 2. Well, you can't add x plus 2. That's as good as it gets because we don't know what x is. So what you're going to do is take this 5, and we're going to distribute that 5 to each one of these terms. So it's going to be 5 times x plus 5 times 2. And then you can kind of simplify each one of these. So 5 times x, well, that's just 5x. And then 5 times 2 is plus 10. In this manner, we can use the distributive property to get rid of parentheses that might be around these quantities, because this really isn't simplified. This is still an equation that, or an expression that needs something done to it, like it's not in simplest form. But we can multiply everything out and get rid of all the parentheses and make it look like this. So the distributive property, you can see with variables why it's necessary, where with numbers, maybe not so much. Okay, so let's do a couple more examples. So let's say now we have subtraction instead of addition inside the parentheses. Let's say I have a 3 times a, let's say 10 minus 4. So again, you can say, well, I know that 10 minus 4 is 6, and 6 times 3 is 18. But we're going to use our distributive property, and I'm going to multiply this 3 times each one of these. 3 times 10, and this sign comes down, so minus 3 times 4. So it's going to be 30 minus 12. Yep, and there's our 18 that we said it was going to be by using the distributive property. Notice above, when we had this sign in the middle, this addition sign, he came down right there. Likewise, he came down right there. So what we did here is we had this subtraction sign in there, and he's going to come down and stays subtraction right there. Well, what does it look like when we are using variables instead of strictly numbers? Well, let's say we have 7 times y minus 3. Again, I'm going to help by drawing these arrows. It says 7 times the first one and 7 times the second term there. So 7 times y minus 7 times 3. And again, it's the negative sign that comes down. I'm not going to call this a negative 3, so don't say minus 7 times a negative 3. That's using the negative sign twice there. We really just want to say it's subtraction and just bring that guy down. So what does that make? 7y minus 21. And again, this expression, you cannot simplify this anymore. That's why the distributive property was the only thing we could do to get rid of the parentheses. Well, what happens when the expressions inside the parentheses are a little bit longer? What happens if we have 3 or maybe more inside? Well, let's say for now we have an 8, and we're going to multiply that by x squared minus 3x plus 2. Well, the distributive property is still good even when there's more than just 2 terms in here. This 8 will go here and distribute to him, the 8 will just come here and distribute to him, and the 8 will come here and distribute to him. So each one of the terms inside is going to be multiplied by this 8. So we're going to say 8 times x squared minus 8 times 3x plus 8 times 2. And again, notice this negative sign I brought down here and this positive sign I brought down here because it's subtraction and addition. And I wanted to keep the integrity of those signs intact. So 8 times x squared is really just 8x squared. And an 8 times a 3x, we're going to multiply these coefficients. This is a constant, this is a coefficient. We can just multiply them and say minus 24x. And then 8 times 2 is 16. So really, and there are no more like terms because this is an x squared, this is an x, and this is a constant. So that's all we can do as far as simplifying. And yet again, we have used the distributive property to eliminate these parentheses and distribute this 8 to all of these terms. Let's look at one more example. When you have a negative number out front that might kind of try to throw a hitch in your giddy-up, so to say, and kind of mess you up a little bit. Let's say we have a negative 3 out here, and inside we have an x squared minus 5x plus 2. Okay, so same thing as usual. We're going to take this negative 3, because that's what's out front, and we're going to distribute him and multiply him by every term inside there. So negative 3 times x squared. Okay, and here's what's going to happen here. This minus comes down and says minus, but we're multiplying the negative 3 times 5x. This minus sign came down here to make this minus sign. I'm multiplying by negative 3 because actually this negative 3 is being multiplied by all these terms. So to keep this negative with a 3, I'm going to go ahead and put parentheses around that. And I know there's 2 negative signs right next to each other, but don't let that confuse you. So now we're going to say plus, because that plus sign comes right there, negative 3 times 2. Okay, so look at what's going on. If you were to take this negative 3 out of this expansion down here, it would just be x squared minus 5x plus 2. And isn't that exactly what we had up here? X squared minus 5x plus 2. Well, sure. All we've done is add a negative 3 to each one of these, paying very close attention to this minus sign and to this plus sign and dealing with them as we need to. So now let's go through and simplify it. Negative 3 times x squared is negative 3x squared. It's the opposite, or we're saying minus a negative 3 times 5x. So I know that these 2 negatives are going to end up making a positive because 2 negatives cancel out and make a positive, or an even number of negative signs. So 3 times 5 is 15, and the x comes along for the ride. And then we're going to say plus negative 3 times 2. And negative 3 times 2 is negative 6, so we're like adding a negative 6, or I could just say minus 6. So there's our answer. So in the distributive property, there's a couple of things that you need to pay close attention to. One, these signs. When you have signs inside here in the parentheses, whether you're adding or subtracting, you need to make sure that they come down appropriately. Also notice that whenever there's a negative sign out front, it will end up changing the sign of everything in here. So this negative was here, so this first term went from positive to negative. The second term went from a negative 5 to a positive once you multiplied. and this positive 2 ended up being a negative. So I was looking at signs just now. So anytime you have a negative out front of your distributive property, it will end up changing the signs of everything inside. Let's actually take one quick look at something like that before we end this video. So if we have example 7, let's say it's just a negative out front, and we have 5x minus 2. What this negative is going to do is actually just negate everything that's inside. Because when we distribute this, we're really distributing a negative 1. So if we multiply by negative 1, what happens when you multiply by negative 1? Really, it just takes positive numbers and makes them negative, and takes negative numbers and makes them positive. It just changes their sign. So this negative times this positive 5x will be negative 5x, and this negative times a negative 2 will end up being positive 2. Anytime you distribute a negative, no matter whether it's just a single negative or negative 3 or negative 73, whenever you have a negative out front, it will end up changing the signs of everything on the inside. So positive went to negative, negative went to positive, and there's no longer a negative sign out front.